Hey guys, so this is the second day of circle notes from geometry. Again, we are going back to geometry because of the shutdown last year and we didn't finish the very end of our curriculum. And this is from the very last unit, like the second last day of notes. All right, this would have been the second last thing you learned new last year in geometry, and we just didn't get to it with the way the year went. So, in order to go back and make sure that you guys are okay with circle equations going forward in Algebra 2 and in pre-calculus, when you use them, I thought that it would be a good idea to go back and reteach you what you should have learned from geometry. So these are day 9 notes from Unit 11 of geometry. And we're still going to talk about center radius form, but we are going to show you a new form that circle equations can be written in called general form. But before we do that, we have to make sure that we understand our notes from the previous day about the center and the radius when a circle equation is in what they call center radius form. So there are two equations given to you, and I apologize that they look a little funny when I saved them as PDFs. The equation form kind of changed a little bit. Things got a little bit smushed in there. But I think you can still read enough to figure it out. The first part of the equation, you guys can read this. You just have to know is a 25. All right. So when they give us this equation here, hopefully you guys remember that when you're talking about the center, you're always going to think about the opposite of the numbers. All right. So if you see a -9 and a +7 in there, the center is actually +9 and -7. Okay, and that the radius is located after the equal sign. However, it's the radius squared in the equation that's located after the equal sign. And so you have to square root in order to figure out what the radius is, and that's going to be 5. All right. In the second one, remember that when you don't see numbers grouped with the X or the Y with parentheses like the first one, that you take that as the center as being 0, 0. Okay. And again, this is your radius squared. And so when you square root, 17 is not perfect. And therefore, we're going to leave it as the square root of 17. Okay. All right. So now we're going to talk about general form. General form is a form of the circle equation in which the parentheses, okay, have been expanded. All right. So remember that it's a set of parentheses all squared. And so we're going to write them out twice. And we're going to go ahead and either use the little area box model off to the side, or if you are okay with rainbows, we can go ahead and do the rainbows to show our double distribution. Okay. The other thing we have to remember is that in general form, the equation must be equal to 0. So our radius squared is going to have to come on over and join the rest of our terms, okay, so that we have equal 0 at the end. All right, many of you will lose a point if you're asked for general form because you guys will bring over your number, but you will fail to write equal 0, and therefore it won't be an equation anymore. So make sure that you guys have equal 0. Third one, it says that the terms of the equation are going to be ordered. All right. They always take your x squared and your y squared and put them as the first two terms, and alphabetical. That's why the x squared comes first, the y squared comes second. Okay. Then your x term and your y term, okay, will be the next two terms, and then your number term, okay, and then your equal 0. So remember to order them like that. You will be fine. And so here we go. We're going to take a look at number 1. Okay. So in number 1, it says given the equation, and we can see that that is center radius because I can tell you what the center and the radius is, which is why they're asking in part A. So we're going to go ahead and say that our center is, remember, opposite of the numbers. So you see +4, think -4. Okay? You see a -3, you think +3. Our center is at -4, +3. And then our radius, remember that this is your radius squared. So square root both sides, and you're going to find out that your radius is 6. Okay. Now, part B says write this equation in general form. And so we have to remember general form is these 3 bullets up above. Okay. That x plus 4 all squared really means x plus 4 times itself, x plus 4. Then there's a plus sign here. Don't forget it. Okay. And y minus 3 all squared means y minus 3 times y minus 3. Okay. I'm going to go ahead and do the second bullet where it says that the equation has to be equal to 0. So I'm going to subtract my 36 and then remember to put my equal 0. I do all of that in the first step. Okay. Now in the second step, it is up to you if you want to do the little area box model to put these two binomials together. Okay. And then the two binomials together in the middle, or you can get used to rainbows. It's up to you to show your double distribution. So here we go. X times x is going to give me x squared. And the cool thing about these is that I'm going to do these at the same time. That's a 4x and that's a 4x for a grand total of 8x. Okay? And then 4 times 4 is +16. keep my plus sign, and then I'm going to do the same thing, but with the y's. Y times y is y squared. This is going to be a minus 3y, but this is also going to be a minus 3y, and 2 minus 3y's is a minus 6y. Okay? Negative 3 times a negative 3, and negative times negative is a positive 9. Okay? Then my minus 36, and then my equals 0. Okay? And I'm going to hit up the last bullet, which says I have to order my terms. So my first term that I'm going to put is my x squared term. He's gone. Okay? Next one up, my positive y squared term. Gone. Okay? Next up, my x term, which is positive 8x. Then my next term, which is a minus 6y. Okay? And then what I have here is 3 number terms, and they have to get combined. So you have 16 plus 9, which is 25, and then 25 minus 36 is negative 11 equals 0. Box them up, and that right there is general form of a circle equation. Okay? It is equivalent to this one. It just looks different. All right, and so that's what we're going to practice today. Okay, so let's take a look at what we have next. Oops. Okay. And in number 2, it says using the picture below, determine the equation of the circle in both center radius and general form. So the cool thing you have to remember is that you can't get general form unless you have center radius form. Okay, so you have to write center radius form first, and then we can go ahead and do the expanding, the equal 0, and the ordering of the terms. Okay, so here we go. Remember that center radius form has a certain structure to it that looks very similar to this. And now all we have to do is insert our center and our radius into it. Okay, right here, you guys can see that this point is the center of our circle. And so we're going to go ahead and write positive 2 minus 3 inside the parentheses. Okay, now we need to look for our radius. And we have bad news about our radius. We do not know. And see how you can't assume here? That circle goes a little over the line. Okay, you can see it goes a little over the line here. See how you don't have a point right directly up above it, down below the center, to the left or to the right of the center. So what we're going to do is we're going to make our radius by connecting our center to one of the points that are on that circle. And we can have 2 options. We can go to P or we can go to Q. I am going to go to Q, and it does not matter. Remember that the radius of a circle is all the same. So it doesn't matter what point I connect my center to. Okay, the length of that radius line segment was going to be the same. Okay, I just have to figure out what it is. So I'm going to go ahead and connect Q to C. And that is my radius. Okay, that is the line segment that goes from the center of my circle to the edge of my circle. And so that represents my radius. Okay, what I'm going to do is I'm now going to make a right triangle out of that line segment, where that line segment is the hypotenuse of that right triangle. And so what we do is we go straight down from the center, and then we go straight over. Okay, and so this is 1 unit, and down below is 3. And now I can go ahead and say a squared plus b squared equals c squared. 1 squared plus 3 squared equals c squared. And 1 squared plus 3 squared is 10. And now to solve for my hypotenuse, which is c, I take the square root, and my hypotenuse comes out to be, well, square root of 10, guys, is not perfect, so we're going to leave it as the square root of 10. Okay, and so now I can go back up and say, all right, I found my radius. My radius is the square root of 10. And then when I put it in my formula, don't forget that you have to now square it, okay, to put it in there. And the square root and the square will cancel each other out, leaving you with just a 10. And there is center radius form, okay? So now what I'm going to do is I'm going to go ahead and expand it. And expand it. And bring over 10 so I'm equal to 0. Okay, now I'm going to go ahead and put these together. So x times x is x squared. Outer is 2x, inner is 2x for a grand total of 4x. And last there is positive 4. Keep the plus sign. Okay, do it again. Y times y is y squared. Outer gives me a minus 3y. Inner gives me a minus 3y for a grand total of minus 6y. And a negative 3 times a negative 3 is a positive 9. Keep the minus 10. Keep the equal 0. Okay, now time to reorder. And I end up with x squared plus y squared plus 4x minus 6y. 4 plus 9 is 13. 13 minus 10 is a positive 3 equals 0. And there is my general form. And this is my center radius form. Has exactly the same information in it, just looks a little bit different. All right, I will see you guys on the backside of notes.